Well, good morning, good afternoon, good evening, and welcome to the New Zealand Australia live views. The Global Star Party. If you're wondering what you've just joined or walked into, this is a live weekly show where we bring you views of things in space, whether that be planets, deep sky stuff, or the sun. In this case, definitely a lot of sun this morning. It's so confusing, this whole time zone thing. So welcome to the Global Star Party. We've got quite a lineup actually today. We've got a whole lot of people including I'm going to say a special guest too, and we have got live views and lots of astronomy pictures as well. So lots for you to do, lots for you to see. We have the Q&A app open. So if you have any questions to ask us, whether that be requests or explanations of what we're looking at, feel free to ask them in that. There should be somewhere, if you're watching on YouTube, some link somewhere in the bottom here where you can click and then you can type away and ask us some questions or just say hello. You can also follow us on Twitter at Global Star Party, and you can join us on Google Plus on our page plus Global Star Party. Nice and easy ones to remember there. So before we get into the whole live views, I should introduce everyone we've got tonight. So first of all, my co-conspirator and possibly the guy that may be asking for $1 million. We have Dylan, whose hair I'm mocking.
How are you?
Well, where are you coming from, Dylan?
I am broadcasting from Australia, but I don't have any live views today. That will come care of Andrew and Paul today.
Talking of which, now he's currently hidden behind the sun because that's where he keeps his evil base. But we also have joining us Paul Stewart, who is currently Hello, and clear skies then, from the looks of it.
There is.
Check it out. Well, we won't too many spoilers now, so we won't look at the picture of the sun too much. Then also joining us with live views, we have Andrew.
G'day, how are you?
And from now with that.
Sorry?
So I can say with that greeting, now where are you from?
Right, I'm from Adelaide, South Australia. The joys of live broadcasting, eh?
Yep, it's always a challenge, especially when it's 3 o'clock in the morning here. We'll go into that in a moment. And also joining us, we have Mike Phillips, and also another guest sat next to him.
Hi, I'm Denise Wright. I'm an astronomy and science teacher. So thanks for having me. Also, Mike.
She's stopping by on her way to a big conference. We're sucked in with lousy weather here, so we're going to share you old that I've taken already.
And also we have joining us today Sophia.
Hi there. I'm in Toronto. I'm an astrophysics student at York University, and I also write. I cover the New Horizons mission for Pluto Safari. So if you don't have Pluto Safari, you should definitely get it. It's a really good app.
Subtle plug there. Awesome. So welcome everyone to this evening, and thank you for joining us. We will be now rambling on. Discussing science, astronomy, and also sharing out live views, which means I am going to jump straight to Andrew's view just quickly here and check out some sunspots. Check that out. Live view of the sun, and you can tell it's live because it's wibbly wobbly with the atmosphere between us and it. So, Andrew, what are you using to bring this to us?
This is currently through an 8-inch f4 telescope with a Canon 1100D DSLR, and of course I'm running through backyard EOS at the moment for the live views.
Awesome.
This is sunspot 2371 according to space weather, which has been rotating around the limb for the last couple of days and just getting better and better. Beautiful north-south polarity, and I think we're going to discover that it's quite active today, like right now during the broadcast.
Well, I believe Paul not only trained his telescopes on it, but he also trained his flare-emitting radar gun thing, and he managed to make it go all active for us. Thanks for that, Paul.
Yes, just especially for the star party, we arranged a little M2 flare to erupt about now.
Well done.
This is because Paul doesn't actually live in New Zealand. He actually lives on a floating orbital base where he controls his many minions and also makes the sun explode. So don't anger Paul, anyone. Anyone wondering what a flare is, Paul's going to explain it in great detail for us.
Yes, a flare is when the magnetic lines or magnetic field of the sunspots sort of snap and emit a lot of radiation at us. So we're pretty much getting us to the center, so I'd expect there to be a little bit of aurora activity associated with this bit of little flare.
That is awesome. And this is in hydrogen alpha light, so this is towards the red end of the spectrum. And so it's kind of it's one wavelength of light that we can look at, but of course Paul's all fancy and he can look in another wavelength of light as well. So I'm going to say, hey Paul, where's that calcium K? There it is. So Paul, can you explain what we're looking at in terms of wavelength and what have you?
Yes, this is calcium K, which is 393 nanometers, which is towards the blue end of the spectrum.
The flare doesn't seem quite as prominent in calcium, is that right?
Yeah, the flares normally emit most of the energy in hydrogen alpha, so you can just see a little white dot just there.
Yeah, can we zoom into that at all, Paul?
In a minute I'll get the big scope on it and we'll zoom right into that.
Okay, cool.
Awesome. Awesome. And talking about zooming in on things and needing, well, you need an incredibly big scope to ever look at it. This is why they're now sending a probe hurtling towards it. But of course, New Horizons is heading and getting closer and closer every day to Pluto and its various companion moons / binary planet buddy, as shown by the GIF that Dylan is sharing out at the moment. And I was just wondering if Sophia could kind of explain, well, the whole thing with New Horizons, what's going on, what's going to happen, and what we're looking at right now.
Sure. So if we could just put the GIF up.
It's a GIF. It's a GIF.
I know. I agree. So in the GIF, what you will see is you see both Pluto and its moon Charon orbiting about their barycenter or their center of gravity, and you will notice that the little X is much closer to Pluto because Pluto is much more massive than Charon is. It's about actually 8.6 times more massive. Now you'll also notice that the color differences in them. You will see that Pluto has a sort of almost beigeish orange hue to it, whereas Charon is like gray. So it kind of highlights the differences between the two, and this is something that is almost like a question that one of the questions that we want to find an answer to. So as New Horizons approaches the Pluto system, we will receive higher and higher resolution images, and with that, we will learn a lot more about it. And so yeah, it doesn't look, you know, like the resolution isn't all that great, but it's pretty great because it's the first ever color picture that we've gotten, or well, a few color images, because that's actually an ensemble of about 9.
Mm-hmm. And can you tell us a bit about the Pluto Safari app as well?
Yeah, Pluto Safari. So it's an app that allows you to almost follow along with New Horizons, and there are so many features in it. Like, it's free and it's available for Android as well as an iOS device. So you can do, like, there are so many features. I haven't even gotten to explore it entirely myself yet. There's a lot that you can do. One of the things, apparently, because one of New Horizons' plans is actually to get behind Pluto so that it can, take spectroscopic data of the planet, and this is, well, the dwarf planet, and this is all to study its atmosphere, and it will sort of get position itself with Pluto in between it as well and the Sun, and you can actually use the app to explore that, which is really cool.
That is awesome. I just thought
that's just one of the things.
I've just highlighted, actually, Mike Phillips here has got this lovely sequence that you should be able to see now of Pluto traveling relative to the stars.
Yes. Yeah, I'm a backyard observer. I don't have a spacecraft. So in 2013, I had picked up a new CCD that I was practicing with, and over the course of 3 different nights, I was able to image Pluto, and you can see the stars remain fixed, and just I think there's dates on there, and it's like less than a week's worth of time between each of these pictures here. So yeah, it's July 22nd, 25th, and 26th. So those last 2 on the bottom is just a single day's worth of relative motion of Pluto. And the part of that is parallax of Earth moving through its orbit relative to the background stars. And then part of that is actually the motion of Pluto. I don't know the percentages of it, but I was impressed to see that you could actually see how far it moves in a single day. So I thought that was kind of neat.
That is.
I certainly have not seen Charon from my driveway, but I do think that other observers from Earth have been able to get a kind of distended view where you can see Charon kind of hanging off of the edge, as it were. So you would see, a picture of a blob of Pluto, and then there's a kind of a little bulb, because the resolving power of most backyard telescopes, even at a 14 inches, is not quite enough. But I have seen someone actually get the right spot for Charon. Certainly exciting times for Pluto, that's for sure.
Yeah. And does that barycentric motion where the moon is spinning, the moon's not really spinning around Pluto so much as they're both spinning around each other with a center of gravity. Is that more kind of evidence against Pluto being a planet? Does that kind of go towards the dwarf planet team?
Yeah, it's interesting because somebody actually posted a question that related to that. I didn't get a chance to answer it because we had to do the show. But yeah, I would say that kind of does, because we have this Pluto is obviously more massive than Charon, but it's only 8.6 times more massive than when you look at like other planets in the solar system, where, for example, Earth, right? Its moon is, the Earth is 81 times as massive as the moon. And that's kind of the trend, right? The planets are a lot more massive than their moons. You don't have something that's just only 8.6 times more massive. So this kind of, it's strange, right? It's not necessarily, it doesn't lend credence or whatever to its being called a dwarf planet now. It's mostly the fact that it just hasn't cleared its orbit in the solar neighborhood. So that's pretty much where it lies. But I do think that that's definitely something curious.
I mean, I was going to say, I don't know entirely much about Pluto. I mean, obviously, everyone's going to know a heck of a lot more about Pluto very soon. But obviously, Pluto has other moons as well. And I believe I read somewhere that the orbits of those moons are kind of quite chaotic. They're not as organized as, say, other planetary bodies in our solar system, where they kind of orbit in that kind of a plane that goes around the equator, etc., in generally speaking, one direction. So do you think that will lend to the idea that Pluto is more, I suppose, I hate to say it because it's been demoted from a planet down to a dwarf planet, but almost like it's like a small collection of rubble almost that just happens to be coalesced around each other. It doesn't really have any kind of significant definition yet, because obviously we don't know that much about it, but it does seem to be like just a collection of rubble around one larger piece of rubble.
Yeah, it certainly kind of seems that way. I just have to note that I also myself hate that term, like demoted. I don't think it was demoted. It was just simply reclassified, right? It just had, they had enough once they had come up and they had seen the way, because when you watch Pluto in its orbit, at some point it actually comes closer in than Neptune does, which is really strange, right? You don't see that with any other planet, and you shouldn't. So I just think it was just simply a reclassification. It's not a demotion, and a lot of people are really upset about it. It's not. It's fine. It's still cool. Pluto's awesome. It's a Kuiper belt object, and we have a spacecraft that's gonna head over there and tell us something about one of the most distant objects that we have in our solar system, right? And yet, yeah.
Sorry, no, carry on.
No. I was just all I was gonna say was that you have the Kuiper belt is really extensive, right? So you have stuff that's super distant, but then Pluto is actually our closest Kuiper belt object. So while it's billions of kilometers away, it's still the closest one that we have, and we're only a month away to finding more out about it. So yeah.
According to app.plutosafari.com, we are 23 days, 9 hours, 31 minutes, and 52 seconds away. So
precisely. And that's another thing people get to do with Pluto Safari is you get to track it live time, right? So it's real time. You will see minutes counting down to its arrival, which is cool.
Which is pretty awesome. Distance to Pluto, just a tiny 27,871,000 kilometers to go. So small drive. Which is pretty awesome. I'm just going to click over to Paul here, who is diligently sharing his live view of that really active area. This one looks like a calcium K view.
It is. We've switched to the 132 mm refractor with the calcium K module in it.
Nice. Obviously, seeing the more you zoom in, the more seeing kind of wibbles you around a bit. Which is why in the UK, if you're using a 3 times Barlow, you're insane. But in this case, still pretty good, actually. You could definitely get a picture out of that if you captured some frames.
And we have to remember that Paul's forecast was for snow today, so it's pretty amazing we're seeing anything at all.
I was going to say, it's because he got that death ray out and blew a hole in the clouds. We know what you like, Paul. And also I'd like to give a quick shout out to Helen Reed and Sharon Almond, who's joined us watching. Currently overcast sky in Kuala Lumpur. And Mike, Helen thinks your Pluto sequence is awesome.
Thank you, Helen. You're the best.
So yeah, so Denise, from an education standpoint, I presume that you'll be talking a lot about Pluto and series and things like that at the moment.
It's pretty funny that you brought all this information up, because I actually have a countdown counter in my course right now. And I think it's supposed to approach approximately 7:30 in the morning on July the 11th. I think there's going to be a lot of, I've been reading NASA Social, which I follow on social media. I think there's been some, I think they're supposed to have, someplace in Maryland, they're going to have the media and all that when that approach happens. I do have my students currently debating, will Pluto be considered a planet again? That is one of my discussion thread forums in my course. That we talk a little bit about that, about why it was demoted, and they read, I think, an article
reclassified.
Right. That was good.
But we read about it. I have an article in there from space.com, and we looked a little bit more about at the New Horizons probe itself, and they read a little bit more about it, because it's been something that I've been discussing with them quite a bit, because teaching, I have a summer class going on right now, and I said to them as soon as I launched it, I said, this is a huge time in astronomy to be taking this course, because we're going to be launching history by getting these images that so we're all, my students and I are very excited about it. Also, over spring break, I was at the Smithsonian Air and Space Museum, and I got to view their brand new solar wall, which is absolutely beautiful, and got to look at how large Earth is compared to the rest of the sun. So that was a neat exhibit. And they were building the New Horizons exhibit when I was up on the second floor, and I'm very excited about it. I keep talking it up a lot to my students. And it's just interesting to hear them, posting about it and talking about it, and they seem very excited also. So from a student and educational standpoint, it's going to be really exciting, and I can't wait to see what the pictures are going to be. I can't wait to see what it looks like and be able to share that kind of information with them and find out what else we're going to learn. So it's pretty exciting stuff.
I was going to say, it is a definitely exciting time to be in astronomy. We've got dwarf planets, or whatever they may end up getting called in this case, all over the place. Obviously, Ceres, Pluto. Heck, New Horizons, there may be an opportunity for it to be shot even further and find something else. I believe that's possibly an option depending on how things go. So it's really
Right.
it's an awesome time.
I've also heard that the moons that we're just referring to were sort of the orbit there's sort of a wobble to them. I was reading on social media a little bit more about them. You were discussing the orbit of those moons, and some kind of a wobble. So that seems very interesting. Something that you wouldn't anticipate.
See, now I wonder what could we possibly discover in this mission that would actually make them reconsider reclassification. Right? That's the question that is running through my head. I don't think that there would be anything major that would go, oh yeah, we totally screwed this up, and it really is a planet. Sorry. I don't see that happening, but I'm just wondering what could they possibly discover that would make them question the classification criteria. Let's say maybe. I don't know.
Isn't it?
I don't have an answer.
Isn't it strictly based on just the size, though? That's why it was.
Well, it has to have cleared its orbit. And all that. There's a bunch of things that they
Criteria,
define for
right,
it, right? And I don't
we
know
talked
all of them
about that.
specifically, but I'm just wondering if we would discover something that would make them refine that classification. Let's say. Do you know, Sophia?
I suppose.
Like if there was frozen water or something like that.
I hope so. I'd like to go to some snowmobile.
I doubt that, but.
I think it's a tough call because it doesn't clear its path. So I don't think that any discovery like perhaps water, right? Or well, of course it would be frozen. That would simply maybe add something to like the classification of dwarf planets, right? I don't think that would really unless there was just some, I don't know what other type of planet you can have other than a dwarf planet or a planet, right? So and I actually just wanted to point out that when you were talking about the wobbles, right? That the moons experience, we also have to keep in mind that Pluto's mass it's pretty small, and it has a lot of moons, and those moons are very tiny. Charon, in particular, is quite a massive moon as compared with the others. And then I think when you have 5 of them orbiting, I feel like maybe it has to do with that, and that has an effect on it as well.
I suppose there could be some kind of tidal forces, etc. They're all pulling on each other in different ways. So.
Well, yeah, because you also have Pluto and Charon tidally locked to each other, right? So now these moons are actually orbiting almost like a two system, right? A double system. So they're not just orbiting Pluto anymore, right? So I feel like that would definitely affect them.
I was going to say, it's certainly, from the standpoint of researching orbital dynamics, things like that, it's certainly an interesting test case for various ideas about how these things can happen. Because they'll talk about binary star systems and whether planets could exist in such systems, things like that. So I think the more we understand about orbits in our own neighborhood, then we can examine further out and theorize in that regard. I just want to say that Paul's getting skunked on with clouds from the looks of it. Andrew is still bringing us some brilliant sunspots here. Helen, actually, I was asking how big these sunspots are. From my own experience, I tend to find sunspots are generally Earth-sized, scarily enough. So, I don't know how big the whole group is as a whole, but generally speaking, they are about Earth-sized, which is pretty phenomenal, really. I'd also like to say that Trevor's joined us. Hello.
I have, yes.
Stealthily joined us.
Good evening, good morning to those. Or afternoon for some as well.
Ah, yes, the wonders of time zones, etc. Although, of course,
And,
we can.
Jason Higley just wanted to jump in there about the Pluto discussion to say that if they find that Pluto is not in hydrostatic equilibrium, it is not a sphere or an ellipsoid, that would cause it to be demoted from even being a dwarf planet.
Being reclassified. I like what Sophia. That's the right thing.
Yes.
Well, hey, I've got a 3-year-old, and we've got lots of space toys, and Pluto isn't in them anymore. So that if that's not a demotion, I don't know what is.
Well, I mean, you can always add all the other dwarf planets in as well, so
Exactly.
your kids would have more toys.
I was going to say I've had that conversation over the bugs. Many of my regular customers, etc. They all know I'm into space because I will waffle on endlessly about it and try to get anyone I know interested in it. In fact, some of my regulars are now actually going and buying telescopes, so it's working slowly. But we've often had this discussion where Pluto got reclassified. They say demoted an awful lot. Sorry.
They do, and I hate it.
and we've had this discussion that obviously we all had to remember the 9 planets, and then obviously that got changed down to 8. And they're like, oh, it's such a shame. And I said, well, your other option here is to memorize 8 or to memorize a heck of a lot more, because Mickey's in there as well. So it's
right.
There'll be a lot more. And if we do discover more Pluto-ish sized objects that remain classified as dwarf planets out in the Kuiper Belt, let's just stick to remembering 8, because some of my regulars don't even get the order right yet. So I'm working on it. But and Paul has got the flare up close. I think he's got a bit of cloud interference there, but still you can see how bright that area is. So that's pretty awesome, Paul. Although, Paul, I'm just going to say, dust bunnies.
Yes, there's a few there.
What kind of magnification are we looking at here at the moment? I mean, what Barlow did you stick in, or is this just a change of scope?
Yeah, I've put the 2.5 Barlow in the hydrogen alpha scope.
Nice. That is pretty awesome. Of course, whilst the Sun is a very dynamic object that will, in the course of hours, completely, well, not completely, but it will change quite a lot. If Paul was to take a photo now and then wait 5 minutes, take another photo, and keep repeating, you would see this flare move and change shape and do some wonderful things sometimes. These flares can be wonderful things to watch, almost liquid-like, as they kind of erupt and spill back into the Sun. So,
I recall you made quite an animation recently too, didn't you, Chris?
I did. I can try and pull that one up in a moment whilst we look at whatever you've got on your screen.
Yeah, so it's, I'm going to go with some current planets now. This is Venus is up in the early evening sky, very high for us northern hemisphere folks here. And I actually try to do these false color images where you combine some ultraviolet and infrared and then use those out of the visible wave into a red, green, blue synthetic. So you move the ultraviolet into blue and the infrared into red, and you make a synthetic green. And you end up with these interesting little cloud features that you can see here. And then I have another one as it approaches a different phase. But the ultraviolet by itself is the one on the right, and then there's the false color here on the left. And then going back earlier into 2013, it was even more of a crescent phase. So I have fun with my ultraviolet filter, although it's such a difficult time to get out now. It's so prominently located, it just teases me. I'm like, coming home from work, I'm like, I want to go out, and it's hard. But I've got a couple, between the little weather gaps here.
Of course, just thinking ahead, actually, in a few days' time, I think it's around the 30th, there is going to be a lovely conjunction between Venus and Jupiter.
Yeah, and I think the ISS was supposed to have flown right near there just about a half hour ago. Sorry if you missed it. I should be more on the ball next time.
Now then, I am going to click on my little animation. So if I then do that. So yes, there we got some prominences on the edge of the Sun there. that were, I mean, this is a time lapse over roughly 2 hours. It's just shy of 2 hours, actually, because then, of course, as standard, as soon as you get a telescope out, clouds want to come and play. So, yes, this was shot between about 8 o'clock in the morning until just before 10. And this is, I shot a frame roughly about every 5 minutes. I had to skip a few frames because clouds got in the way, but you can see quite a bit of movement there. Some of that will admittedly be from atmospheric seeing, but for the most part, you can see in the larger loop on the top right there, there's this kind of like puffball that shoots out at the edge of the sun and kind of joins its main arc brother. That's the way I'm going to describe it anyhow. Very unscientific, of course, but...
When you described it as very liquid-like, it is very liquid-like, and it's not very... it's almost like a cross between fire and liquid, but it is another state entirely, which is plasma. Yeah,
I mean, this is if I had some NASA-style technology, of course, I could see the magnetic loops that this eruption would be actually following and flowing around. Admittedly, you can't see that unless you've got some very fancy gear. And I don't have a few $1 million to spare, unfortunately. So, but this will do nicely. I mean, to give you a sense of scale as well, the top of the arc on the right-hand side is about 85,000 kilometers off the surface of the sun that I measured. So you could fit Earth comfortably within that arc and have plenty of room to spare, which is, you know, the scale of these things is quite incredible. And it's one of those things that I think, if you're trying to get people interested in astronomy, the pretty pictures go so far, but also I think if you give them a sense of scale, give them an idea of the distances involved in these, and the temperatures as well, because I mean the sun is of course phenomenally hot. You know, putting sunglasses on and waiting until night time doesn't quite work with this, but that is always something that I think if you can convey the sheer size of these things, as much as it is tricky, I think it's a great way of getting the kind of people interested and enthralled by it. And also views like this are pretty awesome to look at. I've had friends over who've been like, "What are you doing? It's daytime. You've got a telescope out." I'm like, "Yeah, check this out." And you show them the sun, and you can visibly see their jaws drop. So it's always great. I think solar astronomy is quite an easy one if you're doing outreach work.
That's actually very true. I just wanted to jump in there and because I'm also part of the team at the observatory on campus, and you know, we do both solar observing as well as nighttime observing, and people just love it. Especially, you know, when you have the sun in there and you have a sunspot, or in the odd time like the solar flare, people just they love it, and it really gets people interested.
Yeah, I was going to say, it's solar astronomy sort of was. Oh, I'm sorry, I'm going to stop myself dead here, and I'm going to ask Andrew, what are we looking at now? This looks planety.
Yeah, this is Venus during the daytime.
Nice.
Oh my God.
Check that out. Venus is very, very bright, but trying to find anything still in the daytime is always tricky. That is brilliant.
We were comparing here that you can see this picture that I took, and I've inverted it to kind of match Andrew's view there. Mine was taken May 30th, so just about 3 weeks ago, and it was just below a half phase. It was at 46% illumination, and it looks noticeably. There's live view here. It's actually pretty cool to see how much it's changed. That was a great view. Thanks.
Well, that's brilliant.
Yeah.
And I was going to say, how far off the horizon currently is Venus for you, Andrew?
It's currently 18 degrees above the horizon.
So not massively high. So this is, I assume, why we're seeing that kind of red-blue split coming in from the light there.
That could be because of the poor quality Barlow I'm using as well.
We'll blame the seeing. We'll blame the seeing for this one. That's brilliant. So yes, we're bringing you live daytime planets, folks. Next challenge: try and find Jupiter. just to be mean there, but you know, I mean that's
okay.
You know, we are looking.
Okay, give us.
Okay, he's actually going to give it a go. Now it is relatively close, so in theory it should be findable. If you find Jupiter in the daytime, I would take my hat off to you, sir. That's brilliant.
And I think Michael had some recent Jupiter to share as well. Michael, do you have that image with the Windupos rotation that you were showing us earlier?
I do. Let me pull up that one. Let's see here.
And whilst Mike is doing that, I'm just going to keep everyone updated, but we currently have 27,856 kilometers to go to Pluto. So, you know, getting closer.
Are we there yet?
So this was taken. This was my Jupiter set taken on a pretty good night in March 24th. I had about an hour or so's worth of time. And I kind of make this little flyby animation by taking a few different pictures that I'd taken across the course of a couple hours and put them into a program called WinJupos that allows me to make this little image map that I can then spin and rotate as I wish. So I did a couple of zooming flybys on it just for fun. Kind of a nice effect. I feel like I'm entering breaking orbit or something here.
That looks great. How many hours does it take to do a full rotation if you wanted to image the whole up?
If you can get it on a single night, it's like 9 hours and 50-something odd minutes. So you can get a full rotation. I think the big challenge when you do it from Earth is that in most cases the planet is going to be real low to the horizon at the beginning, and then by the time it reaches the peak in the sky, when it culminates, it's good conditions, and then as it goes back down towards the tail end of that 10-hour period, you're looking through a lot more atmosphere again, like sunrise, sunset. Your conditions are going to be poorer on the edges. So typically what you can do, and I haven't been able to do it this year, is you can do like a Mercury night where you end up with you'll end up with some cloud shift over the course of 2 or 3 nights. But if you get them, within 2 or 3 nights, you can actually get the whole rotation without having to deal with those uglinesses of the edges, let's say.
Excellent.
And
I have a photo of that.
I was going to think Paul got a little bit miffed that some daytime planetary was being pulled out, so he's decided to up the ante from New Zealand, and he's got some daytime moon.
There you go. At least he's got clear skies.
Yeah, all right. That's pretty awesome.
That's nice.
That is brilliant. But of course, Mike did manage to get this epic picture of Jupiter.
Yeah, he's got live. I'll take live over these static, right? I feel I'm cheating to some degree because this is, first of all, Jupiter pictures from last year. It's not even from this year. And second of all, I've probably taken 30 or 40 nights of average, I don't even want to look at it again, pictures to get this one nice one. And this was, the best of about a 2 hours set of about 30 or 40 individual images that I cherry-picked. This one as the best, and spent some real serious meticulous time on it, because when the air settles down and sits still, the planets just hold there, and you're like, oh my God, this is great. And you just press record, right? And you can get as much as you can. I think I had probably 150 or 200 gig from that one very night. And I made an animation out of this one too that I don't have it locally here. I've stuck it up on YouTube, so I'll be sure to reshare that one at my feeds later.
So that is one thing that anyone that tries to photograph anything in space will tell you about when it comes to planetary or lunar. Seeing is absolute king. If you have a night where the seeing is steady, not only is it an absolute treat to look through an eyepiece, but in terms of imaging, you really are hitting that record button as often as fast as you can. I mean, you've got detail on one of the moons there, which is spectacular. I mean, the seeing makes such a difference. You can have it one moment where you're getting nothing but Jupiter-like fuzz, and then the next second you can see those beautiful details. So seeing is absolutely king. And also using the red channel as a luminance channel, as used in this image, really does help as well. Pro tip there. Now I'm just going to click on Andrew here for a second when it catches up. I think we're still looking.
Oh no, I did find it. I just moved again, so.
Give us a holler when you found Jupiter for us.
Okay, no worries.
Awesome. Now, Denise, I mean, we were just talking a little bit about educational outreach, especially with like the solar astronomy and obviously with New Horizons and the whole Pluto thing. I mean, do you find yourself using live stuff like telescopes, etc., to show students, or I mean, what do you use to really get them engaged in a more practical sense?
Well, it's interesting that you asked that question. I'm from South Carolina, in the States, and our state museum just recently had a $23 million expansion, a planetarium, an observatory, a 4D theater, and in the observatory, we're working with a historic 1926 Alvin Clark 10-inch telescope that we've hooked into live lessons, just like we have here in a live hangout. And I hook in with my astronomy class, and we hook in with them live with the museum. And we talk about the sun, and we do live solar observing in a virtual environment, just like we are in right now, as well as we look at the night sky. You're hoping that you get a really good viewing night when you open the roof and have your students in session with the museum. But we always know that sometimes is not possible. So we, bring in images that we take photos with a CCD camera. But I'm in the first year I was one of 5 teachers that piloted it this past year, and it was been an amazing experience. I went out to the museum for a week, and we used the observatory. We also visited the University of South Carolina Library, where they have the largest collection of historical documents from Isaac Newton to William Herschel, from original books, as well as the museum the South Carolina State Museum is the largest, has the largest collection of historical telescopes in the world. So there's telescopes in that museum dating back from the 1700s. So also I had the opportunity, since I do teach them online in a virtual sense, I conducted a live field trip where the students from throughout the state actually met me at the museum, and we did, we actually did some live solar viewing as a class there inside the observatory during the day, and did a planetarium show and all that. So having that aspect and being able to bring a live telescope, just like we do here, into an online classroom for my students has been amazing, and we've done several of these. It's very similar to what we're doing now with the students. So it's definitely bringing astronomy to life for my students across the state. So it's been a really exciting project. And we have this summer a bunch of other teachers are going to also they're going to expand the program and sort of be bringing it into classrooms through Google Hangouts, through FaceTime, through Skype. And last summer they brought a special guest. I got to hang out with Charles Duke from Apollo 16. He was on the mission in 1972, and he is a South Carolina astronaut.
Oh, yeah.
So that was a lot of fun, being able to have a one-on-one conversation with him about walking on the moon and his experiences of being there. So that was sort of a very almost like very emotional for me as a science teacher, especially astronomy, to have that kind of connection. And I actually got this moon signed by him, and it's actually in my home office. It's huge like size, like the model sitting in my office with his signature on it. So that was a lot of fun, and it was pretty inspiring. So I really enjoyed that.
That is awesome.
Well, yes, I'm in North Carolina now because I'm flying out tomorrow morning to Colorado, but I'm from South Carolina. But anyway,
Awesome.
yeah. So hopefully I'll get some good views out in Colorado at the University of Boulder this weekend.
Yeah, fingers crossed, and don't buy any astronomy equipment because that always brings clouds.
I know. So hopefully we'll get some clear skies out there in Colorado. We'll see what happens. I have a night, I think, set up for Tuesday or Wednesday that I'll be observing at the University Observatory there. So we'll see.
Fantastic. I'm just going to head over on to Andrew here for a second, who has got some kind of sunspot movement thing going. Oh, look at that.
What in the heck? Oh, wow.
Now I like it too because cool. As I teach my students, they appear in pairs, and there's 2 of them. So that's sort of neat. There. And is the darker region warmer, or is that cooler? The darker region on the spot.
Cooler.
Is the cooler? That's right.
The darker region is cooler.
That's right. And where are we in the sunspot? It's 11-year cycle. Where are we in the cycle? Do we know at what point?
Just over the halfway point at the moment.
Okay.
Oh, fine. Okay. He's,
Here's a bird.
yeah, it's a bird.
What I'm liking there is that not only do clouds try and join in the fun, but birds, aeroplanes, in fact, anything that's in the sky will try and join in there. That's brilliant.
Yeah,
It's
that's
fantastic
good capture.
capture.
That's one of those moments where you're like, oh man, why didn't I record that?
And I have a lab in my course where you can actually determine you're trying to determine the sun's rotation based upon the movement of the spots.
Yeah.
That's a basic astronomy 101 kind of lab. And I'm trying to do that in a virtual sense and have them do that.
That's cool.
So,
I actually did that too in one of my classes.
right, and that's one of like a really basic lab that you do with students. So
That's awesome. And Dylan here is currently sharing out the sunspot groups. This is a photo I believe you took quite recently, Dylan.
Yeah, so this is just a couple of days ago, just to show people that these are the same two sunspot groups that we're seeing today. 2371 was the one that was flaring out, and 2367 was the one that Andrew was just showing before with the bird, and they're rotating away now. I'm just going to share a bunch of stuff that some of our viewers have submitted over the course of the week. There's one live view here from Spain, just because we are all about live, and that's a live all-sky view from the Spanish Grand Telescope out there, which is quite nice.
Nice.
And let's see what else we have here. We have 2 nights ago, this was my view just outside.
Dylan, you have turned into a speech bubble thing.
Wow.
Okay, and this one here, can you see this one from Thad Zabo?
Yes.
Okay, so this is a big mosaic that's done with a hyperstar and a Celestron 9 1/4, stitched together with a one-shot color CCD. Really intense. If you get a chance to see our Flickr group, you'll see this and a bunch of other viewer photos that have been submitted, and they're all amazing. We definitely don't have enough time to go through all of them today, and hopefully Thad will stop by and have a chat sometime and share some more of his images as well.
I was just going to say, Thad did actually say he wanted to join us this evening and take part, but unfortunately he had a few prior commitments, so I believe he will be joining us in a coming episode. And Thad is fantastic. He's got all the science locked in his brain that he can talk about his images, and he just takes some epic pictures too, so it'd be good to have him join us.
Yeah, and I don't know if you're still on me, but this one's as close to live as I'm going to get for Nebula right now, but this was taken about 13 hours ago. It's the War and Peace Nebula, but it's called War and Peace because in infrared it looks like a skull and a dove, I think, but in just normal RGB it looks more like a lobster. So this is the Lobster Nebula. And this was a mere 19 minutes of exposure, so I can't believe I got this for 19 minutes. But yeah, that turned out pretty well.
Now, I have just quickly jumped over to Andrew because I don't know if you guys can see this, so it's quite clear. There is a fuzzy kind of pinkish white blob on his screen right now, and I'm going to guess that is live Jupiter.
Now, how many hours till sunset, or how many minutes? Because that's not an easy thing to get, and you got it. I see it.
Yeah, at the moment it's 20 past 12 in the afternoon, so I've still got quite a few hours to go.
Yeah, wow, that's really good then.
So
Yeah, Jupiter's right there in the middle. So
we are really hitting up on the solar system. We've had a live sun, live moon, live Jupiter, and live Venus. So that's and some pretty live, well, as live as you can really get with nebulas as well. So that's not bad going. I'm just going to skip over to Paul over here, who's got some live moon. Check that out.
Nice.
Now then, I want to name the crater, but as I've expressed before, I'm terrible at that. Unless it's Plato or Hercules, I can't name them. I'm terrible.
Alright, Chrysium. I'm not good with the moon either. I'm just guessing.
Yeah, I think that's right.
Although, you know what I did once? I actually took a picture and uploaded it to Google Images, and it will match the photo to other things, and it actually identified the crater for me once. I was like, wow, I can't believe it actually did that.
That's a good trick.
So you could take a picture and upload it to Google, and it'll tell you.
Thank you, Google. What would we do without you and Wikipedia? And talking of which, another planet, Michael's showing there, is, well, Saturn. Now,
Venus, comes out in the evenings. Jupiter's right behind it, and then a little later comes Saturn. Saturn just came off of opposition, so as you roll through the evening, you'll get a nice showing of planets there. And it's been a rough go of it, but the rings are opening up, and so I'm trying to get as many pictures as I can. This is the best one I've gotten this year. This was taken that same night that I showed the other Venus photo, May 30th. So if you can get out, even in a small telescope, Saturn looks actually really, really cool.
that is pretty awesome.
Yeah.
Now, actually, talking of Saturn and lowness, I'm just going to share something here. Now, this is not live, but this shows you what I'm struggling with at the moment. He says, trying to find it. There it is. Now, that is what I'm having to deal with in terms of seeing conditions, and that's actually a little bit cherry-picked because that's the PIP version of it. So it's taken the best frames I got out of it and run it together. And so as you can see, it's still wobbling around quite dramatically.
About what I usually get lately too. So.
It's a struggle, but it is, if you've got even a small telescope, it's still a wonderful thing to look at. So I want to check it out. Now, Paul is... you see, now Paul can't be outdone, can he?
What have we got there, Paul?
Very wobbly Jupiter.
Nice.
Paul. One day I'm going to have to set you a real challenge, like live Mercury. Come on, crack it out.
I got it. Give me
we
one
had a
minute.
question in the Q&A saying, Shah wanted to know, do we really need to use WinJPOS in addition to AutoStack or Registax to get the details to jump out more?
Yeah, no, you don't, as evidenced by what Chris was just showing, right? You can take a live view and just replay it back, and it's still pretty darn impressive, right? To get the absolute best out of it, you definitely need to smooth it, shape it, and hammer it with a bunch of tools. So minimally what I would do, and I think what Chris had mentioned, was to run it through a sorting, stacking program like Registax or AutoStacker, because it'll go through, the umpteen number of frames that you have, find the best quality ones, and then put those together to make a smoother, less noisy image, and it'll average out all of the little dust spots and idiosyncrasies of seeing and things like that. So stacking and sorting certainly gets you a lot farther. And then once you start to sharpen, minimal sharpening will get you really, really far. And it's at that point you've gotten the most out of your image that I think you can. You can do a lot more to it, but it's kind of splitting hairs at that point.
Now,
Cool.
I was going to say we have...
Mitchell, hello.
Hello.
Hey, can you hear me?
We can hear you. We can't see you, but we can hear you.
Yeah, I'm trying to get this thing figured out.
Technology. It's always good. It's Hangouts. It's great for sharing space live, but also it can give us gremlins too. But, I mean, we have had quite the showing of live stuff tonight. Oh, there's me on the screen. That's upsetting. So we are beginning to actually, unfortunately, get towards the end of the show. Believe it or not, that you've survived an entire episode of this. So thank you for joining us. First of all, I really want to say thank you to Sophia for joining us and bringing in all the Pluto.
Thank you so much for having me.
It's been awesome. Thank you. As a quick update, we're still getting closer. 23 days, 8 hours, 54 minutes to go. So, everyone should keep an eye out on Pluto. And if they want to do that, I mean, what would you suggest then?
I would definitely suggest downloading the app. The app has through the app you'll have access to live, real time. The real-time distance to of New Horizons to Pluto, as well as you'll have views on it. So, and the news also there, and you'll get all the all the press releases and such, the most up-to-date news there. So definitely download it.
So definitely. So from the looks of it, you can check this out. It's on iOS, it's on Android, and you can also go to app.plutosafari.com. It seems to be there, and you can check it out.
That's right.
I was quickly browsing around whilst not ignoring everyone here, of course, but I was quickly browsing around over here on the laptop, and yeah, I was checking it out. It looks pretty awesome. So definitely worth a go. And thank you, Sophia, for joining us tonight.
Yeah, and I'd also like to say thank you to you, Chris. I believe it's 4 a.m. Is it 4 a.m. over there?
It's getting on that way, and I will be up in another 5 hours or so to go back to work. So yeah, but hey, it's good. It's fun. I love doing this. So I also like being mean to Paul. So that always I'll get up at any time to be mean to Paul and go, hey, find us something in space. So thank you, Paul, for joining us and bringing us. Let me see now. The Sun, the Moon, Jupiter, and I think you also got Venus in there, didn't you? So so that's insane. You're doing pretty well, Paul. Thank you for joining us.
My pleasure.
And you can check out Paul. A lot of his work is on Google Plus Paul Stewart. You can't miss him. He's the one with the icon, the insane rig inside a green dome. So he's quite easy to find, and some epic pictures. Now then, we also had a late joiner with Mitchell, who's bringing. Is that live? Are you bringing us live Saturn?
That's last year.
That's last year. Well, it's you know. Oh yeah, you can tell Ashley. I should have sounded more professional. Like, oh yeah, it's not tilted that far yet. But I can also see myself. That's disturbing. But well, thank you for. I know it's late on, and you obviously haven't been able to quite get set up. But thank you for joining us. Please stick around for the after party. That's where we all go crazy and have beers, and you public guys don't get to see that. So but thank you for joining us. Also, thank you to Mike Phillips and Denise for joining us, who's also showing us Mercury right now.
Yeah, someone requested Mercury. I'm a collector. See?
Okay, next, I want to see series. Just saying.
I have that one too.
Oh. Right, I'm gonna have to offer out harder challenges. In fact, anyone that's watching the Q&A app, next time we do a show, I'm going to be particularly mean and go, right, make crazy demands of everyone in our panel. Just kick on everyone, and we'll see if we can make them sweat a little bit. But no, thank you very much for joining us, both Mike and Denise.
You're very welcome. We're happy to be here.
Thanks for having me. Thanks for inviting me.
Of course.
So hopefully, Mike, you don't get skunked on with clear skies.
One of these days it'll happen. It's always a challenge to get it to land on the right day of the week. We'll give you guys a heads up maybe next time it's clear.
Yeah, no, that'd be brilliant. Mike has an insane telescope. It was light buckets go. It's pretty much like a swimming pool, so it's pretty awesome.
Pretty much.
So hopefully, hopefully we can get some live views from that brilliant telescope. Also, Trevor joined us tonight. Now he has brought in some epic live stuff before, but more silent part this evening. Sorry.
That's all right.
Thank you for joining us and for taking. It was good. Hopefully, how are the skies with you at the moment?
Skies are good. Skies are nice and blue.
Ah, awesome.
Nice and blue. Unfortunately, I was gonna do Jupiter, but it was just too low for me to actually do anything with. So I have got some good shots of daytime Jupiter. So
awesome.
Unfortunately, a little bit too low. But in a few more weeks, it'll be a different story. If we have one during the day here, and you have a night one again, then it will be a different scenario.
Well, we are mixing them up, so I think next week will be Australian nighttime, and then swapping back again. So yeah, we should hopefully catch it when you're able to bring it to us. That'd be brilliant. Thank you.
I'm going to try and give you some live fuzzies next week. I'm going to really, just get some really good distance stuff so we can actually see. I'll share it with everybody so they can actually see what's out there with a bigger aperture and what you can see and get.
That will be absolutely brilliant. Thank you. And also welcome to my co-conspirator, so Dylan.
It's always a pleasure. This is episode number 4, and I think it's one of the best yet. It was just fantastic. Looking forward to doing it again all over next week.
That's okay. Next challenge is to get an asteroid slamming into the moon and photographing that live. just saying, please, someone out there, give us an asteroid to hit the moon. That'd be awesome. But Dylan, thank you very much for joining us. Brilliant, always good, and thank you for sharing out those brilliant pictures from the Flickr group. And then also thank you to Andrew.
You're welcome.
Thank you very much. And so we can find all these wonderful people in various locations. I shall put them all into the YouTube video that will go up later on, and I shall share out on Twitter as well. We will, so you can find all these wonderful people and the kind of stuff that they do, because most of us are on Twitter, Google+, Instagram, a combination of all of the above. I'm sure someone's probably got a MySpace kicking around somewhere. You never know. Although, of course, we're trying to ignore Facebook because, well, it's Facebook, so, you know, it's full of cats. It's not really that useful these days. But you can find us on Twitter at Global Star Party. We tweet out events, we tweet out links to some of the pictures and stuff that we're doing. It's kind of one of those things that if you can't be bothered to read something particularly long, then we tweet it out nice and short. So you can join us there. You can find us on Google Plus as Plus Global Star Party. We also have a Flickr group now, where if you would like to have one of your images or a few of your images featured on the show, you can find us on our Flickr group. He says, desperately trying to find Flickr. Dylan, you can always bail me out here and tell me the link to the Flickr group. He says, it's okay, I'm almost there.
It's got a funny long number, really.
Yes, no, we haven't got that yet. You can find, if you type in on Flickr, Global Star Party, you should be able to find us. It's a group full of awesome astronomy pictures submitted by the guys that are on the show, and also general people who are watching. So please feel free to submit images, give a little description of how you got that image and what we're looking at, and we'll be sure to share it out live on air. And again, this is very much a project about bringing live views and some not so live views to the kind of the global community. You know, if you like space and astronomy, then this is, you know, hopefully a place to come and enjoy some live stuff and some crazy chat as well. But if you have a telescope, an SLR, a camera that you can plug into it, and internet access with a webcam, or even not, you know, we'd like you to join us and see if you can share out your views to us all. That'd be fantastic. So thank you very much indeed for watching. We'll be back next week. Next week's show will be timed and lined up so that it'll be nighttime in the Australian, New Zealand kind of area of the world. Although, of course, if you're coming from Japan, you should be able to give us some nighttime views as well. So let's not exclude all the other areas as well. But basically, if you're that side of the planet, it will be nighttime. And I will look less tired, and it'll be maybe sunny outside. You never know. You never know. I might actually be able to do some live sharing of my own for the first time in this show. So it's in, and I'm not set fire to anything. Thank you for joining us, and I think we should say good night and goodbye. So thank you, and please come again.
Bye-bye.
See you later, guys.